So here we'll take a look at the ImGuiLayer file, and what that basically is doing is it's providing us a layer of ImGui, which is an external third-party library, which is what we're using for the graphical user interface. So the ImGuiLayer inherits from the layer class, which we'll talk about in some of the section. It's got the constructor, the destructor, it's got virtual, it's overriding the virtual functions provided by the layer class, and then it's got its own private functions. So this ImGuiLayer is actually in the sandbox. It's being used as it's being pushed onto the layer stack as an overlay. So it's an overlay layer, and as you can see in the application class, when you push an overlay, what it does is it on the layer stack it first pushes that overlay, that layer as an overlay, and then it runs the onAttach function of that layer. So let's take a look at that onAttach function. So that's inside the ImGuiLayer CPP file. So the onAttach function is doing some of the ImGui specific stuff, so it's creating the context, it's setting the style color to dark, and then we create this ImGui IO object, input output object, and we're setting some of the boilerplate stuff, so backend flags, so things like has mouse cursor, has set mouse cursor. The more details about this can be seen in the ImGui documentation, but this is boilerplate stuff, and then we're setting up some key map for input and output. So, and for that we were using glfw keys. So these are macros that provide the integer value for specific keys, and at the moment we are using glfw macros, but at some point we're going to use engine specific macros, but this is for testing purposes, so we are using the macros provided by glfw. For instance, we can even take a look at where it's being provided. So it's in glfw3.h here, and basically it just defines all these different keys and their integer counterparts. Okay, so coming back to the ImGuiLayer CPP file, we go down after we've defined these key maps. So actually we can take a look at the key maps themselves. So if I go into key maps, it's something provided in imgui.h, and key map is basically an integer, it's an array of integers, and if you put in a specific type into the integer, it's going to get the value for that. So in this case, but the default is the ImGui key, but if I go here where this is defined, you can see all these other different keys in the ImGui key enumeration. But that's a side track of what we were going through, so I'm going to stop here for going through the library specific functions and come into the ImGuiLayer.cpp again. And next thing we do is, because we're using OpenGL as the graphics API, we were using the OpenGL implementation of the ImGui library, so we're initializing the OpenGL specific functions needed for the ImGui library. And so that's the whole onAttach function, so that's like the initialization of the ImGui layer. And so once a layer has been attached to the layer stack, we in the application side, we can see, like in the onEvent function, we go through not just in onEvent but also in the run function, which is running constantly. We run the onUpdate function of every single layer. So let's come into the onUpdate function. Again, we're doing some library specific stuff, so we're creating an input output object, and then the next thing we're doing is we're actually creating a reference to the application, and the way we're doing that is we're getting a reference to that application. So if we come into if I open application.h, then you can see that we have a private variable which is a static pointer to the instance of that application class, and since it's static, it's going to be same across all the instances of the application. So meaning it's just going to be it's going to be the same for every single instance. And then in here we've got an inline static function called get, which returns a reference to this pointer to the instance of the class that we're running. So that's how we access that reference to that instance through the get function, and we store that inside the app variable, which is a reference. Okay, so then we are doing io.displaySize, which displays this, and we're accessing the size of the window through this reference to the application window, and we're doing app.getWindow.getWidth, and same for the height. Next thing we do is we set up the time. So we store we create a variable called time, which is a float type. Then we get the time using the glfw library and this function glfw get time, and we typecast that to float. The io.delta time is then calculated, so it's assigned to mtime, which is so mtime is a private variable in ImGuiLayer.h, and its default value is 0. And we assign this io.delta time to that value if it's greater than 0. So the first time you run this, it's not going to be greater than 0. So then we instead assign that to time minus mtime. So whatever that time is at the moment minus mtime, which is at the beginning, it's going to be 0. Else, if this is greater than 0, then we assign it to this. So time minus mtime. Otherwise, we just if it's not greater than 0, so the first time we're running the file, we assign it to 1/60. The next thing we do, we assign mtime to the time before. So the next time we go through this onUpdate function, this time is going to be the new time, and this mtime is going to store the previous time, so the last time we ran this application. So that's basically going to provide us the length of the frame in time in seconds. The next thing we do is ImGui OpenGL new frame, so we create the new frame and we run the new frame. So again, boilerplate code that we've copied from the implementation for that ImGui OpenGL implementation file example stuff. And the next thing we do is create a static bool show variable equals true. I think this is like responsible for whether we want to show the window or not. And then we do the rendering stuff. Again, boilerplate code, nothing much to talk about. Instead of like going through the documentation if you want to explore further in these cases. So then we come to the onEvent function. Now this is the important function because it lets us interact with the window that we're creating. Otherwise, without this onEvent function, we have the window rendered onto as an overlay in our window, but it does not. We can't really interact with it without the onEvent function. So again, if we come back to the application.cpp, we've got this onEvent function for every application that's running, and in here we go through every single layer on the layer stack and we run their onEvent function with and passing down the event that we received. So in the ImGuiLayer we create all these dispatcher.dispatch, and we check whether the event we have passed in here in the template argument is the same as the event that was passed into the onEvent function as a parameter. So if it's the same, then it's going to run that specific function. Whichever one of these dispatch function gets the match will run the specific function that's been bound here, and we'll go through every single one of these functions. And bind event function is same as what we saw in the application file, it's the macro that we've defined. I think we've defined it in the core. So we've defined it as a function that's passed in here, and we then use the std bind to bind that function to the this. So whichever instance it's running in, we bind that to that, and we tell it that it's expecting a placeholder, which is a parameter that it's expecting. So going back up here, so when we get a dispatch and we actually get a match and we run one of those functions, so we run one of these functions. So we've got on button pressed event, which takes in an on button pressed event, and we create an input output object, ImGui input output object. We set io.mouseDown to mouse down and whichever button's been pressed. So this is going to get whichever button's been pressed when we set that to true, and when that's released we set that to false. Mouse event, similar stuff. We set io.mousepause.x to, and we get the x value using the getX function. So wherever the mouse has been moved on the window, we get that value from our event that's been passed down. Same here. And how do we know about these I/O related event? We can just go to the implementation for I/O. We can go to ImGui I/O structure, which is in imgui.h, and here you can see it's been clearly defined what's what and what it contains, like display size, display time. If you come down here, we got all these mouse pause, mouse down, mouse wheel, and all that. So we can use this ImGui structure to see what we need to implement in our input in our ImGui event system. So if I close that, coming down here, so most of the stuff is pretty simple. A new thing that we've added here is on key typed. It's a new type that we have actually added in our event system itself, and this basically lets us type stuff in the input fields in the ImGuiLayer. So before this, we do get, because we have provided on key pressed and on key released functions, the system can detect those key presses, and it can, so it can detect all those key presses. But when we actually try to type it in to one of the input fields, it does not actually print that character in the input field, and that's because of something that's happening in the background. Just key press is not enough to type keys into an input field, and that's why we've provided the on key typed event. And if we go into Windows window, well, we've actually first provided that in key event. So basically we've just created a new type of event, and it's inheriting from the key event class, and it's taking in a key code, and from the key event class we can see that we can get that key code using the get key code function. The next thing we're doing is we're actually using the glfw event system functionality to implement that in Windows window.cpp. So we're doing glfw set char callback, and this function basically takes in the window context that we have, and the callback function takes in the window, glfw window, and just an unsigned int, which is going to be the key code. Then we create the window data. We typecast that to window data, and the key. Then we use the key type. We create an event of type key typed event, and we pass in the key code, and that's basically passed down the callback functions. So that's how we are getting that event, and that event is basically passed down all these layers, and that's how we were able to get it over here. So in the on key typed event itself, we are just we're checking whether the key code is greater than 0 and less than this much, and if it is, then we use the io.add input character, and we typecast that to unsigned short key code. So even though this is an integer here, and what we were getting back from here would probably be unsigned int, none of that matters because at the end it is getting unsigned, casted to unsigned short, so that's alright. So if I run this now, so if I go here, press F5. So before, actually if I go here, before we actually implemented that, we would, so if you look here, if I press any key, you can see in keys down, you can see what key's been pressed and the integer associated with that key. And even with modifiers you can do that. So before we implemented the onKey typed event, we could still do all this stuff. So the system would be able to tell that a certain key was pressed, but when we actually try to type that into, so if I go into like console, if I just try to type something here, we can do that now after we've implemented the onKey typed event, but before that we wouldn't actually be able to type stuff into the fields, input fields. So that was the example for the ImGuiLayer. It's not a permanent thing. We're probably gonna get rid of it and make a more more efficient version of this, and that's more engine specific, so it uses the engine API rather than relying on GLFW key codes, etc. But that's more or less how you would create a GUI overlay into your application.